Alrighty, geometry. In this video, we'll be doing some algebra practice with congruent triangles. So let's jump right into it. Okay, so we're told that triangle LMN is congruent to triangle WER. Determine the transformation that took place to map the two triangles onto each other and determine the values of X, Y, and Z. So when I'm looking at this, it looks like the transformation that took place was a rotation. Okay, so I've answered that part. The next thing that they want us to do is to find the values of X, Y, and Z. I'm going to zoom out here a little bit. And so if I want to determine those values, I need to be able to set up equations and set those equations equal to each other or equal to something to help me solve. So that's where that statement, this congruency statement, is going to come in handy. So I'm going to go ahead and just start off marking my diagram. So L is Angle L is congruent to angle W. So angle L and angle W, and those are the right angles. And so since M and E are the second letters in both of those triangles, then that means angle M is congruent to angle E. Okay, which means that angle N is congruent to angle R. Alrighty, so just looking at that, it looks like I've got enough information to solve for my y variable. And here's why. I'm looking at the triangle that I just highlighted in yellow. Angles of a triangle add up to 180 degrees. So that means that if I take the measure of angle W plus the measure of angle R plus the measure of angle E, they should sum, or they will sum, to 180 degrees. Well, angle W is 90 degrees. I can see from the diagram that angle R is 29 degrees. And for angle E, they gave me the value of y. So I'm going to write y in there. Okay, so then from there, I want to combine the 90 and the 29, and that's going to give me 119 plus y equals 180. So to solve for y, I'm subtracting 119 from both sides, and I end up with y equals 61. Okay, so I've solved for y. It does not matter if you solve for y or x or z first. That doesn't matter. Okay, so now I want to go ahead and I can see that I can solve for angle n. I'm sorry, I can solve for my x value because angle n is congruent to angle r based off the congruency statement because those are the last letters and based off the way I marked my diagram. So angle n is congruent to angle r. So that statement is going to help me set up my equation because they give me an expression for angle n. They told me angle n is 3x minus 1, and they told me that angle r measures 29 degrees. So there's my equation, 3x minus 1 equals 29. Now I'm going to add 1 to both sides to start solving for x. Divide both sides by 3. And we get that x equals 10. So I've solved for x and I've solved for y. The last thing we need to solve for is z. And it looks like that we're using segment lengths for z. So I'm going to assume that ML is congruent to EW, but I want to just double check that based off my congruency statement here. So EW is the first and the second letter in this statement. Is that true for LM? And if I look at this one, yes, it is. So that means that these two segments are congruent. So EW is congruent to ML. And that right there helps me set up my final equation. So I have Z plus 50 equals 5Z minus 10. And now I can go ahead and solve. I'm going to add 10 to both sides. I get Z plus 60 equals 5Z. I'm going to subtract Z on both sides. So I end up with 60 equals 4Z. And then as a final step, I want to divide both sides by 4. And so 60 divided by 4 gets me 15. So we found our value for Z. And we've answered the question. We found values for x and y and z, not necessarily in that order, but that doesn't matter. Thanks for watching.